Welcome. Just a note before we start, there's a lot of people here, and if you don't get a good view, it will be recorded. And also, I've put all of the samples, the Visual Studio samples and the LinkPad samples online. So if you go to my website, which is albahari.com, that's my surname.com, that's the first thing there, is you can download all of the samples from this. And I've also made an extended lot of samples which goes into some more detail, and it slows things down a little bit. And you can download that directly from LinkPad, and I'll demo that in a moment. But so there's quite a lot of additional resources if you can't squeeze into the session. So my name is Joe Albahari. I'm an O'Reilly author and the author of LinkPad. And so if you can probably imagine, I'm pretty passionate about C#. And so when I started announcing the new features of C# 5, then I was kind of like a kid in a toy store. And this is something that's been brewing for a long time, the concept of having asynchrony inside the programming language. Because you think about, what have we got right now in C#? We've got classes and structs and in interfaces, virtual methods. We've got really powerful things for dealing with the units of data and the units of functionality in our program. But in terms of dealing with concurrency, there really isn't anything that we've got to help us abstract that and work at a higher level for concurrency. And this is a kind of a bit of a game changer. When you first look at it, you think, this looks a bit weird. But when you started using it, and this is a test for it, is it's very hard to go back to programming the old way. So I think a lot of you here are probably asynchrophobic. I know I certainly was. And here's an example. I decided to write a method to download a series of web pages sequentially, and I wrote them in a truly asynchronous manner. Most of you probably won't really know what it is, because what it means to be asynchronous, because asynchrony is just so difficult right now. We don't do it. We do multi-threading. But I decided to write it genuinely asynchronously using the event-based asynchronous pattern in C#, which was introduced in C# 2. This is a number of lines of code it was. I rewrote that in C# 5. You can look at the difference there. And we've got a similar difference in cyclomatic complexity. Now, most of you will not ever write that code in Orange because it's so difficult. You are not doing asynchronous programming. You're doing multi-threading, and you're thinking in terms of threads rather than asynchronous operations. So I'm going to divide this session into two parts. The first part is a shallow dive, but it won't be so shallow that you'll hit your head on the bottom of the swimming pool. We will look at exactly what asynchronous is, what it means, how it differs from multi-threading, and the problems that it creates, why we need new keywords in the language. And the second half of the session, I'm going to speed it up. We'll go into a lot more detail, and some of the stuff you'll understand, and some of it you'll have to go over later. So let's have a look at the history of C#. Every version has had a theme. The theme of C# 4 was dynamic programming. But if you look at the bigger picture, at the CLR, the broader theme was parallel programming. It just so happened they didn't need to make any extensions to the language in order to make parallel programming happen. And what did they give us for parallel programming? They gave us 3 libraries. It wasn't that we couldn't do parallel programming before Framework 4. It was just really hard. These languages made it easy. They gave us 2 approaches, a functional and imperative. What do we mean by functional? Functional is declarative. With LINQ, you say what you want, and the runtime works out how to do it. With imperative, we say how to do it. How do we say how to do it? Using loops, for loops, while loops, for each loops, do loops. We use if-else constructs. We use try-catch. We use variables whose values change. That is imperative programming. That is what we're most familiar with. Now, which is better, imperative or functional? It depends, exactly. C# is not a purist language. It's pragmatic. Use whatever gets the job done. Some jobs are better done functionally, some are better done imperatively, and there are some jobs that are equally well done either way. Now, if we take that whole issue of parallel programming, that is half of a larger issue of concurrency. Concurrency is more than one thing happening at a time. The other half of that issue is latency. Latency means anything that takes a while to run, either because it makes the CPU hot or because we're waiting for something like a web page to download. Now, just as what we could do parallel programming before Framework 4, we can deal with latency now. It's just pretty difficult to do. So they've given us two libraries to make this easier, two solutions. And just as they gave us functional and imperative before, they've given us functional and imperative now. The functional is reactive framework. The imperative is asynchronous functions in the next version of C# and VB, which is what we're looking at now. And just as with parallel programming, there are some solutions you can solve equally well either way using the imperative or the functional approaches. That's not a failure. That's their commitment towards the multi-paradigm approach. Now, latency is becoming more of an issue because of the growth of cloud-based systems. Systems are becoming more interconnected. And having a responsive user interface is no longer considered a luxury. People demand it. There are two sources of latency. There's anything that makes the CPU hot, we call compute bound. Anything else is I/O bound. I/O bound stuff like downloading a web page or sleeping where we're waiting. So what have they given us that we can play with right now in async functions? They've given us a CTP you can download. That CTP patches the compiler to add new keywords, but it doesn't patch the CLR. It's additive. So they've given us a 50K DLL that works with it. You are allowed to ship that. In effect, everyone gets a go-live license automatically, which is quite cool because if you really can't live without it, you can actually start using this now. Now, those two keywords they've added provide transparent support for continuations, thereby making asynchronous programming easy. So what are continuations and what's asynchronous programming? Well, a couple of years ago, my router died, and I had to ring the help desk for my ISP, and I was hoping to get her. But instead, I got this guy here. And for 20 minutes, a recorded message told me how important my call was to them. And during that 20 minutes, I was on the phone, I was blocked. My user interface was blocked. I couldn't interact with anyone or do anything. I was waiting for 20 minutes. I didn't think that was cool at all. But then a year later, I had to call them again. I had another problem. But this time, I got a different message. It said, please enter your phone number and press hash. And they said, we will call you back in 20 minutes. 20 minutes time, I got the phone call back from them. My ISP, they had changed their queuing system from synchronous to asynchronous. Synchronous, you wait while something completes. Asynchronous, you give it the instruction, it goes away, you do other things if you want, and then it gets back to you when it's finished. Now, that callback at the end, there is a more precise term for a callback that occurs once at the end of an operation. It's called a continuation. Here's a summary then of the difference between sync and async. Synchronous is also called blocking, or synchronous call. Synchronous method is blocking, and asynchronous method non-blocking. Now, I've given you this analogy because there is another way of solving the problem, and we've all done this. You ring up your ISP, and they put you on hold. What do? Speakerphone, all right? And then you are multitasking, or more accurately, you are multi-threading. Right? So with one thread, you're listening to that recorded message, telling them how important your call is, and then your other thread, you can do other things and maintain a responsive user interface. What is the difference between those two kinds of concurrency? What is the difference between speakerphone concurrency and true callback concurrency? Polling? State? Yes, and what's the underlying reason that drives those things, difference? open connection. The big underlying difference between the two is that with speakerphone concurrency, the caller manages the concurrency, whereas with true callback concurrency, the callee manages the concurrency. Speakerphone concurrency, the caller manages the concurrency by spinning up a thread. And we've got a problem right there because it means that every asynchronous operation or concurrent operation requires a thread to be tied up for the duration of the operation. With asynchronous concurrency, the callee manages it, and the callee has the option, with I/O-bound jobs, to potentially coalesce thousands of asynchronous operations onto a few threads. That can only be done with asynchronous concurrency. But there are more advantages as well. You might write a method once and call it 20 times. Now, with asynchronous concurrency, if the implementor, the callee, is doing the concurrency, you only have to write the concurrency once instead of writing it 20 times. But moreover, what you're doing is a finer grained, as we'll see. With asynchronous programming, your concurrency is fine-grained. Advantage of fine-grained is it can actually eliminate a lot of the scenarios for needing shared state to begin with. So not only is there less multi-threading to worry about or concurrency to worry about, but it actually can get rid of some of the thread safety problems entirely. This is why it's quite exciting. So we've seen here are the advantages. We've gone over these ones here. That final one is that with asynchronous programming concurrency, we can create a high-level abstraction around the concept of an asynchronous operation. And we can then program these things. In the same way we can do this with classes, we can do this with asynchrony. So you'd say, well, I'm going to take this operation and that operation, and I'm going to do something with those without even knowing what those operations do. And that's another big advantage you can get, high level of abstraction. A note on waiting. If you're waiting, you're not doing asynchronous programming. Say you're doing something, you're doing X, your boss comes up to you and wants you to do Y. Your boss doesn't wait while you finish X and then say, do Y. What will your boss do instead? Hopefully not interrupt. It may involve an interrupt, but your boss will say to you, hey, when you finished X, continue by doing Y. Your boss will attach a continuation. The whole reason we wait is we want to do something when X is finished. Right? So the asynchronous equivalent is rather than waiting for it to finish and doing it, we say, when you're finished, do this other thing, and then exits the room, and it gets on with other things. So having said that, let's write an asynchronous method. And I'm going to forget all about APIs and everything. We're just going to go back to first principles, write the simplest possible method we can. And we'll start off with the synchronous version. This is a synchronous blocking method to download a web page. Returns a string, the HTML that's downloaded. What does the asynchronous version look like? Well, it won't return a string, it will return a void, right? Because it returns straight away to the caller. That's how we might call our synchronous one, right? We get the HTML, we write it out. Here's our asynchronous version. We return a void, we pass in the URI, but now we need to tell it what to do with the result when it's finished. That's our continuation. And here's how we would call it. You'd say, when you're finished, continue by writing out the result. So that's our continuation we're passing into that method. That is the simplest possible asynchronous method we can write. But there's a problem with it. There is something important that protocol is lacking. What is that? To know when well, we know when it's finished because that continuation will fire. Progress is, that's a valid thing, but it's relatively minor. There's even a more basic than progress reporting. Error handling, exactly. What if that throws an exception? There is no way it can communicate that to the outside world. We really want that exception to be communicated to the continuation. So we can write it out maybe. There's no way of doing that. So we need to make that protocol more elaborate. Maybe it can take another delegate or action of string, comma, exception. It starts to get messy, right? Now, as it turns out, they've already solved this problem. Well, they've tried to at least. There have been 3 attempts at trying to solve the problem in the .NET framework. The APM was the first, the EAP was the second, and the third one is called the TAP. Now, we're going to go into these in a moment, what these acronyms mean. But good news, I was going to start with the APM, but it might traumatize you for life if you've not already used it. So we're going to actually start with the latest and greatest. And introduced in Framework 4, there was a class called task. Who's heard of a task? Right, most of you. A task represents a concurrent operation. So what we can do is, instead of accepting that action string, we can return a task of string. That says I'm giving you a string in the future. And a task is really a signaling construct. It's a bit like a manual reset event. It signals when an operation is finished. So this guy can signal when it's completed. But it's more than just a signaling construct. It's a value-added one because it can hold a result property. It has a result property in there. It also has an exception property so we can report errors. And most importantly of all, it's got this hook, the continue with method. This is a hook for us to attach continuations. So if our method returns a task of string, we can call it like this. We can say, start your download, and when you're finished, continue by writing out the result. Now, seemingly, we've solved the problem, right? We can do asynchronous programming now, right, with tasks. What's missing? Why do we need new keywords in C#? Why isn't this good enough? And to show you why, let's go back to the very first example we had. We're going to call it slightly differently now. I want to call it 5 times in a row in a loop sequentially. Simple, huh? But how do we asynchronize that? The problem, the continuation is not just that right line, it's the whole rest of the loop. So look what happens now to our code when we try and call that. Right, we call it getAsync in our continuation. We can't do this inside a for loop. Right, we have to now instead create a field and stick that field up there. And if we want to make this reentrant, or possible to call it more than once, we actually have to put all of this into a private nested class. Now, that's a simple case. That's a for loop. But what if we had nested for loops? Imagine how hideous it's going to get there. The problem is that continuations do not mix with imperative programming constructs like for loops, while loops, try-catch blocks, if-else statements. All of this stuff that we know and love and that we program with, this does not mix with continuations. So we're forced to write really ugly code to actually do asynchronous programming. Consequently, we do not do asynchronous programming. It's just too difficult. Now, this is exactly the problem that C#5 fixes. We can now write this. This is legal code. It will work. You notice how similar it is to our synchronous version? That is the rule with async programming in C#5. Programmers write with synchronous and sprinkle these 2 keywords in here. Let's have a look at what those keywords do. Async keyword, that really doesn't do a hell of a lot. It simply says it's a signal that this method contains 1 or more await keywords. The await keyword, well, if you want to know literally what that does, it translates it back into that horrible code, right? That's what the compiler does. But from a logical perspective, what happens when it gets here, it evaluates that expression, which is non-blocking, it will return immediately, and then it jumps out of the method, just like a yield return. Except before it jumps out, it attaches a continuation to that guy there. It says, when you're finished, jump back in here and then assign the result to the HTML and then continue where you left off. Now at that point, if this was faulted, it will throw that exception back onto this code here automatically for us. Very nice. The other really nice thing it will do is it captures the synchronization context when you await. So let's say you were on a UI thread when you came in. When you come back, you will come back onto a UI thread. So this takes the thread safety issues away. It takes the plumbing issues away. And it means you can now program the way you always have. And you are actually writing continuations. This is a continuation. You just don't realize it. It's so easy to use in a way that's quite magic. So let's write a real one. So I've written a simple script to download 4 web pages in a row, and we're doing it sequentially to begin with. So we're creating an array of web pages, of URIs, and the reason I want to download them sequentially will become clear later. Actually, these ones here, these are graphics that this page uses. So later on, we're going to read that one, we'll parse it with regex, and get all these links out, and download these ones after. But I've hard-coded them now for simplicity. So we're downloading them. We'll run this and see what happens. Okay, that all works. That's our synchronous version. Let's turn this into a user experience. Well, I'm using WPF, so I'm going to consider this an experience, even though it's not very good, my UI. So here we are. I've created a simple window with a Go button. We'll use these ones later. They're invisible. And I've got a list view to report the progress. Each time it downloads a page, it's going to add an item to that list view. And this will tell us the result at the bottom. Now, let's look at what we've got in the click event handler of that button. I'm going to call the populate method in there. And we're going to start by clearing out the list view items, disabling the button. This is the same code that we had before, our synchronous code. Only difference is I've added a code to that list view to add an item that we could display the length of that web page. I'm using this page length class, which is something you can bind to in WPF, and it's pretty simple. So the other thing I'm doing is I'm catching any exceptions here. Obviously, something goes wrong, we want to display that to the user. And the finally block, I'm ensuring that we clean up by re-enabling that button no matter what happens. Now, you can probably guess what happens when we run this, right? Because we're calling a synchronous blocking method here. We run it, the whole user interface just goes unresponsive while it's working. Nothing shows up until it's all finished, and then in one go it all comes up. So that's no longer acceptable nowadays to have UIs like that. So how do we solve this? Well, that one approach is the speakerphone multi-threading. And this is the speakerphone concurrency. And this is something we're probably doing now. You either spin up a new thread or use background worker, and you start the thread going, and here's the code inside that populate worker. Because we're on a thread, we have to worry about thread safety. So we have to call dispatcher.beginInvoke every time we want to update the UI. Right, this is a real pain. We have to get back onto the UI thread to be safe. And background worker will help with some of those, but that one I've highlighted, for instance, we will still need to do that if we use background. Background worker is just it runs it on a pooled thread, and it helps us a bit with some of this invoking. But really, this is conceptually what we're doing. It's not a great solution at all. It doesn't scale well on a server. And we've got the thread safety issues, and it's difficult also to refactor. And I'll look at that later. So how are we going to use async functions to fix this? First thing is we go to the Solution Explorer and add a reference to that library, which I've already done. This is that 50K DLL with the supporting functions. And inside that library, it's got hundreds and hundreds of extension methods to give you task-based versions of all of these long-running methods. So for instance, we've got here download string. If I look at that now, there'll be an extension method called download string task async. And you notice that returns a task of string. So this will return immediately to the user, and then it gives us this hook, the signaling construct that we can then use. Now, once I call that method, I can simply await that in here, and then add the async to this method here. And that's all we have to do now. I run this, and we've now got an asynchronous version. So we've got a responsive user interface. We can still have buttons that work. And we've solved the problem with just having a couple of extra keywords and in a really nice way. I've got this whole program. Thanks. This whole program is actually single-threaded. There are no threads anywhere here. We've done concurrency without threading. That's a really nice thing to have to worry about. The only thing we have to be careful is that you know how await, with await, like yield return, right? It returns at that point and then jumps back in here. So potentially, it could actually end up re-entering itself if the user clicked the button twice. That's why we've disabled the button at the top, right? That's the only thing we need to worry about in terms of thread safety. So we've looked at what asynchronous programming is and what continuations are, why we need it, the benefits, the problems it creates, and how those are solved with those language keywords. And this completes the shallow dive. Are there any shallow questions? Yes, sir.
What would happen if your application wanted to finish before the task async?
Okay. So,
in the case where that window, if you wanted to close before it.
okay. Question was, what if the user wanted to close the window while the async operation is still happening? And we're just about to look at that. It's done through cancellation. We pass in a cancellation token. Yes, sir?
Does the debugger handle it and jump around with the callbacks and everything?
Debugger actually, for a CTP, does a surprisingly good job. It's not perfect, but it does a pretty good job. It's rather like with iterators. It does a reasonable job with that. Okay, we'll move on. Now, the first thing someone asked was talking about cancellation. And I'll just point out first that we're going to we're segueing into the deep dive section. So this is going to, we'll speed up a bit. This is a 400 level session. Now, all of these examples I'm giving and the studio projects are available on my website, as I said before, by surname.com. If you get lost or anything, you can retrace your steps. The first thing you can do is that any method which returns a task is potentially following something, or these methods follow something called the TAP, the Task-Based Asynchronous Protocol. Now, it sounds fancy, but all it means, if you want to write a method that follows the TAP, return a task and optionally accept cancellation tokens and progress reporting objects if you want to support those features. So if we have a look at this guy here, that's the method we're calling, but we can also call a version that accepts a cancellation token. Now, these are the same tokens that you've used in Framework 4. Who's used or who's not used cancellation tokens or not heard of them? Anyone? Oh, about a third of the people. I'll mention briefly what they're about. It's actually quite simple. A cancellation token wraps a flag which says, please stop what you're doing. So the idea is that anyone who gets one of those checks that flag regularly, and then if that flag is true, they will typically throw an operation cancelled exception on itself, which will bubble up the stack. So it's a cooperative cancellation pattern. Now, we'll put cancellation in here. And as it happens, I've got a cancellation button which is collapsed, but we can make it visible. And let's have a look at what we've got in the event handler for that. I've created a cancellation token source. Now, this is a driver for a cancellation token. They don't want you giving a cancellation token to someone and then that person actually hitting the cancel button, because they want to have one class for cancelling and another class for listening to cancellation. So you can for security, that's quite good to separate those concerns out. So this is the guy that actually lets you do the cancel. So we create a new one of these guys. We call cancel on it when we want to cancel. Now, all we have to do up here is pass that cancellation token source, pass the token, that gives us the cancellation token, into that method. And this will now throw an operation cancelled exception onto us if the user cancels. So all we need to do, so I can run that now, hit go. I've not enabled the cancel button. So the other thing we need to do up here is button cancel.is enabled is true. So we can start this thing going now, and I can click the cancel. There's a bit of a delay there, and there is a slight flaw to the asynchrony. If you do start playing with this and you notice that flaw, it's actually deep down in the bowels of the APM, which is these methods they've given us, these async methods, they thunk down to lower level APIs, and there is some issues in the APM which hopefully they'll fix for the release. So now I've got cancellation. And if we wanted, we could catch the operation cancelled exception. And we could also, in the close method for the window, we can activate those tokens and cancel any outstanding operations. Now, the next part is progress reporting. How do we do that? I'll go into that briefly. It's not really part of asynchrony as such, but it is quite important when you're using this. And what they've given us is a new class, a new interface called iProgress. So you notice we've got iProgress of download progress change of NARGs. It's a big, long, ugly class name. Because that class already exists in the framework, they're recycling it. It's the event arguments class that's used for another asynchronous model. So iProgress is a really simple interface. It has one method called report. If you've ever used reactive framework, it's equivalent to an iObserver with only the onNext method. So they've also given us a concrete type called progress, which you can create one of these, which implements that interface, so you don't have to implement it yourself. So you gain a new progress class. The type will be that download progress changed of NARGs. And when we construct it, we can then, it'll have an event that we can handle, which will fire whenever progress changes. There's even an easier way to use it, which is in the constructor. You can actually put in there an action delegate telling it what you want to do. So in this case, I've got a progress bar in there, and you just need to make it visible. I want to set its value to the progress percentage, which is, this is on the event args class. This reports the progress percent. So that's all we have to do. And now I can pass that object into the into this async method that implements the tap. And now we've got progress handling as soon as I make that progress bar visible. Now, we're reporting progress on each individual page rather than the overall progress. To do overall, it's a bit of extra code. Obviously, we have to do the math there. So now we've got progress reporting and cancellation. A nice feature of this progress is that if the person who reports progress, calls the report method, is on another thread, it will automatically marshal you back to the synchronization context. It will capture the synchronization context when instantiated. So that gets rid of your kind of thread safety issues in a UI. So yeah, this is a fairly complete program now in terms of progress reporting, cancellation, and so on. There is something, though, which is wrong with that method still. Who does anyone do into best practices? I'm not really myself, but is anyone into best practices here? What's wrong with that method? It's combined with what? Or does it combine that it shouldn't?
What you're doing on the result.
We've got too many concerns in there. Exactly. We've got business logic and UI mixed in together. And let's say we wanted to call this method that, well, we've basically written a method that downloads a series of web pages in sequence. What if we wanted to call that from somewhere else in the program? We have to copy and paste the code, because we've intermingled it with all this other stuff that does reporting and exception handling and everything else. Right? We don't even have to go as far as unit testing. We just want to call that somewhere else in the program. Now, our synchronous one, interestingly, was a lot better. Let's go back to our synchronous one. I've written a class here, which we can call this from anywhere. We can call this from anywhere, right, in the program, and it'll get the web page size. Now, we need to somehow do the same thing with our asynchronous version. And this is the second part of the functionality you get with asynchronous functions in C#. Any method for which has that async keyword, instead of returning void, you can return a task. Remember, this is a signaling construct. which will fire when job is complete. So when this method finishes, anything that calls it can then await that and knows when it finishes. Now, this doesn't actually help us in this particular case because we don't want to call this method, right? We just want to leave this as a void. But what we do want to do is take this functionality here and extract that into a method. So let's do that. Let's go refactor, extract method, and we'll call this get page length. And now, the problem is we're awaiting in there. So this has to be async, right? And we need to return a task. But we're not returning an ordinary task. We need to return a task of integer because we're actually returning a value, total length. The type, that total length of integer. Therefore, we must return a task of integer. Now, when you do that, when the compiler sees you've got a task in there, task event on an async method, it will create a task for you, which it manually controls through a task completion source, and it will signal it with that value. It will populate it when it finishes. If it throws an exception, it'll put the task into a faulted state, so anything that awaits it will get that exception propagated. So now all I need to do now is add the await keyword here, await get page length, and now this compiles and runs just like it did before. So we've actually now written an asynchronous method. We've almost written a method that follows the tap. We've not quite abstracted it enough for the tap yet, right? Because we've still got this reference to the list view, and we've also got the cancellation token in there. So we need to factor those things out. And that's pretty easy to do. We can factor out this cancellation token just by putting it as a parameter in there. And we can also factor out the progress object quite easily by having that as another parameter. What about this guy here? How do we kind of deal with that? How do we generalize that? A delegate? Yeah, we could definitely go. I would say yes. A delegate would be a great way to do that. But we can actually recycle another feature I just demoed very recently in conjunction with the delegate. And what's that? iProgress, yeah. So we could actually make this another progress reporting object. And I call this is my cheeky extension to the tap. You actually have a method that has two progress reporting parameters. One for the overall percentage complete, and the other for any other special events that you want to periodically report. So I've written a version which does exactly that. We'll look first at the generalized version without progress. So here's our tap version that supports cancellation but doesn't support progress. Now, let me just compare that with the synchronous version. Spot the difference? See how similar they are? How do you do asynchronous programming in C#5? You do synchronous programming, you add the await, the async here. That's it. It's actually much simpler to use than it is to really understand deep down. You don't actually even need to understand it all that deep down, as it turns out. It's a bit like, iterators. Who uses iterators? Yield return. People use yield return. Like, there's a lot of stuff going on there, and you don't necessarily need to know all of it, but they're actually much easier to use, than you might see when you first use them. It's the same with this. So that's our version without progress reporting. We'll go back to the version with progress reporting. And we've created one progress object for the integer, and the other one, this is the overall percent complete. And this other one lets you report events whenever it's got a new page length to report. It then fires that one there off. And if you look at the total amount of code in there, it fits on one page, even with these large fonts. Let's have a look at the same thing done with the old version of the asynchronous API that they gave us before this. It was called the EAP, the Event-Based Asynchronous Pattern. Well, actually, the full name is the REAP, the Retarded Event-Based Asynchronous Pattern. Using events is retarded, in my opinion. The reason they did it was that you could be cited in the Windows Forms Designer. That was their decision for using events. So let's have a look at this. Remember that we're not just consuming an asynchronous method. we're actually writing an async method. Can you see that? Because in order to get a modicum of reusability, you have got to write asynchronous methods. You can't just consume them. So we're going to write a method using the EAP. You don't have to know anything about the EAP except that it's bad. And I'm going to show you, here's the code to do it. These are the fields we need. Those are the events you've got to provide. The cancel async, and we need thread safety in there. The fetch page, and so on, and so on, and so on, and so on. And this extra class we need. And at the end, we're down to 136 lines of code to do the same thing. That was that original opening slide I had. And I did the measure on the cyclomatic complexity as well on that. So we've seen now that not only can we use them, but consume asynchronous methods, but we can also write asynchronous methods with almost no effort at all. So any more questions on anything we've had so far?
Can you do this functionally?
The functional version of asynchronous is Reactive Framework. If you want the really broad question, the broad answer to that, there is, in fact, an interesting limitation on asynchronous methods in that if you want to enumerate it through a sequence, there isn't anything to help you asynchronously fetch each member. There's no asynchronous move next. But if you are working with sequences, that is a strong indication you want to go functional and should look at Reactive Framework. We'll look at the integration between Reactive and this a bit later. So let's go into more detail on async functions. We'll run some scripts in LinkPad. So we'll start off with a simple one which downloads a web page asynchronously. Now, LinkPad does recognize async functions, so you can put the async on the main method and then await inside your code. So if I do this, what you'll notice is the query completes, it finishes, and a few seconds later, up comes the result. So that's a kind of asynchronous behavior. Now, if you're kind of playing with it, rather than downloading web pages, it's easier just to run a method that just waits for a while. So they've provided one called in the task class called delay. But because task lives in the framework for assemblies, they couldn't add static methods to it because it's an additive. So they created another class called task.ex, which are all the extra methods that will end up in the task library eventually. For now, it's called task.ex. And delay, what that does is it returns a task, and look at the plain task, that's signaled in had that many milliseconds. So this doesn't say wait for 2 seconds. It says return immediately and then jump back 2 seconds later. So this is the asynchronous equivalent of waiting. So I run this now, it finishes, query finishes, 2 seconds later, outcome's done. So question arises, how would you implement that task.ex.delay method? We've seen how to write an async method that calls other async methods, but how do you write a bottom level one at the scratch like that? And I hinted at that before, which is you use this thing called the task completion source. This has been there since Framework 4, and it lets you drive a task without any heavyweight threading options. So literally a task becomes a signaling construct. So we tell it, we're using a timer now, I'm using a threading timer, and I'm saying in that many milliseconds time, signal that the task is completed, and the reason we've got a null in here is that we don't have a result to report, which is saying finished. So if I run that now, we'll get everything finishes in 2 seconds time. We get that. Now we can also return a value. So now I'm doing something more useful calculation. And this says we're creating a task completion source. The type is integer, which agrees with what's in there. And I'm setting the result to the actual value, which is 42. So run that in 4 seconds time. That should come back now. So this is how you write a bottom level async method. But in the actual case, we don't even need to do it like that because we could just write that in terms of calling task.ex.delay, right? So I've done that in the next one. I've just written this now by making this async and awaiting that task.ex.delay. So we're saying in here, return immediately to the caller, and in 4 seconds' time, jump back in and return 42. And so run that, and we should get the same result. Now, you notice that I've awaited. See, this returns a task event, and I've awaited it immediately. It's a good practice when you're doing asynchronous programming. Whenever you call a method, an async method that returns a task, await it immediately, unless you've got a good reason not to. The reason is that if you follow that principle, your program will run sequentially, which is what you want by default. You only want to introduce concurrency or parallelism in those places where you need it. You don't want to do it by accident. So if you want sequential by default, always await. But imagine we can do this in 2 steps. So what I've got now is I'm calling that method and assigning the answer to this variable, and then I'm awaiting it. Now, why would I do this in 2 steps? It gives us the ability, if we want, to do other things in here which will now kind of run in parallel. Right? Now, this is what we want to avoid unless you actually need to do it. So this is a much nicer way of doing parallelism than threads, because all we do is just put code in there. Now I've got parallelism. So much easier than threads, and we keep it tightly scoped to this little bit of code here. And this is much nicer again than threading. So what sort of code might we want to put in there? What if we want to call that answer 3 times concurrently? Right, we just run that 3 times. So we get 3 tasks of int back, and then we await them each in sequence. So what should happen now is 4 seconds later, we should get the 3 of them returned all at once. So it should finish. 4 seconds later, we'll get, here we are, get them all coming back. Now, they've provided a method to make this kind of pattern easier. Rather than doing that, there is a method on task.ex called whenAll. And you just give it a params array of tasks, and it returns another task that completes when all of those tasks that you passed in finish. So that's why we await it, because it doesn't wait for those tasks to complete, it awaits for them to complete, right? It's purely asynchronous. So we're doing hardcore async programming now, right? This is how does it gets. And it's pretty cool, because look how much code we've got in there. We are blocking no threads, right? We're using no threads. We are programming asynchronously. We have no thread safety issues. This is so much easier than before. And the other good thing is the scalability. Like, we're doing 3 of them, but what if we want to do 100,000 of them? I've got 100,000 using a LINQ query to create 100,000 tasks, start them all, they're all hot, they're all running. I'm going to when them all. WhenAll to wait for them to complete. Let's run that and see what happens. Again, in a full second's time, we've actually got 100,000 answers to that question. You try doing that with threads. Here's a more practical example of how you might use this. What I'm doing now is I've taken that first example of the parallel web page download and I've made it real world. So what we're doing is we're first downloading. We pass a URI into this function, and we first download the HTML from the page. And I'm using this ugly regex guy, which is not perfect, but it's good for the demo. And we're getting all of the matches in that HTML where you've got source equals, and then I'm parsing the URL, typically a picture or a JPEG or whatever, and then I'm creating all of these parallel tasks that will start running, that will download all of these in parallel, and now I'm waiting for them all to complete with this await whenAll. And then finally, I'm using a LINQ query at the end to sum them together. So run that now, and this will now give you the total size of the Stack Overflow page, plus all the graphics and other resources in there. Okay, we can actually inject a dump in here just to see the pages it's downloaded, so I'll put dump in there. Run that again. You notice it finishes. No threads involved, and here we are. Those are all the pages it's the other resources it's got, and it's downloaded, and that's the total size of all of those resources. Now, because async is such an easy way to do parallelism, then the question arises, can I do compute-bound stuff as well with it? Now, obviously, with compute-bound stuff, you're not going to get the kind of scalability advantage in terms of like coalescing lots of operations onto a few threads, but you certainly get all the other advantages. And it's very easy to do compute-bound stuff. You just call task.factory.startNew, which runs a task on a pulled thread. That was part of framework 4, that method. And so I've now done rewritten this important question in terms of a calculation with prime numbers. So we're going to take the number of prime numbers in the first 10 million integers and divide it by that magic number. And after a period of time, I'm using plink here as well to make it more fun. So that will, after a period of time, that will return the answer. And I want to run that on another thread. I'm telling it, OK, I do want you to use another thread now, but I want to await it like anything else. So we can now await task.factory.startNew and dump out the answer. We'll run that. And a few seconds later, we should get the answer. There it is. So let's dig even deeper now and look at what the compiler actually does here. So we've got, here I've got created a simple series. I've got 3 async methods that just wait for a second and return A, B, and C. I'm going to call them sequentially. If I run that now, we're just going to get A, B, C. 3 seconds later, right, because we're doing it sequentially. How might the compiler translate that there? Now, if you're familiar with iterators, it uses the same engine it does for iterators. So it actually has to create a state machine. So what were previously local variables are now fields in there. And it has to do all this ugly code here with continuations. If we this code here, yeah. Yeah, that's what it does. It awaits each one in sequence exactly like that. So when it's finished A, then it jumps back up into the top and then awaits the next one. And when that finishes, it awaits. So I'm writing out S1 plus S2 plus S3. So that's why we've got ABC. I see what you're saying. So I didn't dump them out here. I could have put S1.dump, S2.dump, and then S3.dump. And then it would have, was that what you were asking? Yeah, OK. That's because I just waited till the end and then concatenated the result. In fact, the reason I did that is that the next version, I've actually written an asynchronous method that returns that concatenation now as a function. So it awaits each one and then returns that as a string. Because we're writing an async function, we need to make sure that type there agrees with this type here. And now we can await it, get the type as a result, and we'll get ABC back. Now, how does it compiler produce that code? It's now got to use a task completion source to do it. And you can see the code's pretty ugly. And this is a simplification, right? But you end up with this task completion source. And at the end, it's got to call setResult on that to get the result in. And it also needs an exception handling block on there as well in order to propagate the exception if there's any error. There's a number of simplifications in here. Most of them are uninteresting. But one interesting one is it doesn't actually call continue with. It calls another method which I've added now to as an extension method called getAwaiter. They've done that for a number of reasons, but the most important probably is it lets you await things other than tasks, such as observables. Anything that provides a getAwaiter method is awaitable. So this purely encapsulates the concept of a continuation. So there's that method that it actually uses instead of continue with. So speaking of which, I've got an example here on how you can await an observable. Now, if you're not familiar with RX, then this won't mean anything to you. But if you've used RX and you want to await an observable, it waits the whole observable to complete, and then the return value is the last thing that it emitted with move next. You can await other things too, like wait handles if you write your own extension method to do that. You can also convert tasks to observables with the extension method called toObservable. And what I've done here is I've rewritten that first query that downloads web pages in a series, but I've done it functionally now using observables, and I'm leveraging that tap method and calling to observable to segue into the functional world. And what you end up with is an iObservable event when we sum up the values, and then we can unwrap that into an int by awaiting it. So we go back, we're using now the async functions again. So as we said, we love functional and we love imperative. So we can do both, we can go between the worlds with this, and it works really well. This is how they've implemented, or approximately how they've implemented toObservable. One interesting thing I'll show you here is that you can also mark lambdas as being async, because a lambda is really it's an anonymous method, right? It's an unnamed method. If named methods can be async, why can't unnamed methods be async? So you just put an async there, and then you can await inside the lambda. Okay, I'm going to do a demo now on the scalability, demonstrating the scalability of this. So I've written a program that it sets up a socket server, and it's got this protocol where it waits for a connection over the internet, and it reads 5,000 bytes in, reverses them, writes them back. And then I've got another program which creates 1,000 concurrent clients. 1,000 of them are going to hit it at once, calling this. Kind of like a really busy web server. Now you may say, Joe, I don't do that stuff. I just use ASP.NET. Web server's already written. Why would you ever want to do anything like this? And I was speaking at a user group a while ago, and I was amazed at how many people were doing this kind of thing. For instance, someone was working in trading or investment banking. They were dealing with thousands of stock tickers that were coming in, and they wanted to read those asynchronously. Someone else was writing a system to monitor traffic on the freeways, freeway congestion. Again, they had thousands of messages coming in from these monitors that they needed to deal with. Doing this asynchronously was an absolute nightmare. It was causing a huge headache. And so this isn't such an unrealistic example for asynchronous programming. So here it is. I'm repeating this whole thing 5 times. Read 5,000 bytes, reverse them, write them back. Let's run this and see what happens. We're blocking in the thread pool because we're doing, this is a synchronous version, right? When we're doing these reads, these are synchronous read. Whenever you block in the thread pool, it is like you are peeing in the thread pool. A little bit of pee is not a problem. A lot of pee and the whole pool starts to turn yellow. This is what's happening right now. Look at the concurrency here. We've got, 30, 40 of the 1,000 requests are getting through. The CLR is not releasing threads into the pool. It's confused by the fact they're all blocking. It doesn't know what to do. About half an hour's time, it will eventually catch up and start and get enough threads in there. But then it's incredibly vulnerable to oversubscription of some compute bound. So it's a very unstable situation. This is just not working. So let's asynchronize this with the tap. Async functions. Very easy. Remember what we do? Change this blocking one to the async version and await it. This right here, change this to the blocking version, await that. And then we need to add the async word here. That's all we need to do. And it's failed. Okay, it looks like it's a VS thing rather than a, I'll run it without the debugger. Okay, so now I'll run this again. And look at the concurrency we're going to get now. Now, how much effort did it take to do that coding? Now, you won't appreciate this unless you've actually used the APM. Who's used the APM? Just a handful of people. And you recovered? I needed to see a therapist after I used the APM. The APM is the very early, in fact, most 90% of the async methods in the framework follow the APM. It's those begin-end methods, the iasync result. And the problem with it is it's just hideously painful to use. And I've written this using the APM. Let's go down and have a look at the code here. I'm implementing it as well, so this is reusable. Look at all the methods you need to implement, all the plumbing in there. This is incredibly easy to get wrong. In fact, most people that write this, there's a subtle bug they introduce into their program where it'll actually work fine most of the time and you deploy it, and then it has a Stack Overflow exception for a reason that's totally unobvious. It took me a while to realize that. So we've got here 180 lines of the worst possible code you can imagine. This can take like an hour or two or a week to debug. This is hideous. But let me show you something else really cool, which is we want to make this reusable so other people can call us. 1 hour job with the APM. That's it. That's all we have to do. This is now, we can call this from somewhere else and await it. Better still, what if we want to take that? I want to take that ping pong and make that reusable. How much work could that possibly be? Again, an hour-long job with the APM to do that, because you've got to implement that whole interface all over again. We can just put extract method and call that ping pong. And we're going to return a async task, and we await it. Done. That compiles. So this is the fact that we can take a complex method, break it down into simpler methods using the familiar programming constructs. We don't have to go into functional monads or anything. It's incredibly simple to use, and this is fully composable, this pattern. Final thing I'll show you before we have questions is I've done some animations in WPF. Let's run this. We've got two text boxes wandering across the screen. Now, it's got primitives for animation, but I wanted to do this kind of with first principles. So the typical way to do this is with a timer. Right, have timer update the position on a canvas. But I don't know about you, but every time I use a WinForms or WPF timer, I feel like I need to take a shower. They're not pleasant things to use, and you can actually work without them now. And what I've done here is on the loaded event of the main window, I'm calling animate hello and animate world, and these comprise of while true loops. Isn't that weird? Well, on the UI thread, we've got a while true loop. We've got two of them. Two while true loops on the UI thread. How is that possible? Well, this is the beauty of the await. Whenever it gets to the await, remember it returns back to the call and it jumps back in 20 milliseconds later. So you can have any number of these while trues in there. You can stick a cancellation token in there as well if you want to end it prematurely. And this is much nicer because you can vary the amount that you wait in between each cycle if you want. And you can also do additional stuff after that and await again before you repeat the loop. So these are the stuff that's really awkward with timers. That's really easy with this approach. So we looked at rather than thinking in terms of threads about programming, how to program asynchronously, we program synchronously and then await instead of waiting. The guidelines about always awaiting async methods unless you want to introduce parallelism, and then you do it in that nice controlled way. And obviously we avoid blocking, we don't do things synchronously. In fact, if you block a method that you're awaiting on a sync context, you can even deadlock. If you look on the forums, it'll explain how that happens, but it's usually because you've done something silly if that happens. We've seen the progression. I didn't burden you with the APM or the EAP. If you don't know those, you never have to learn them now. And the task-based async pattern, very simple. We've implemented it ourselves. Your method ends in async, returns a task or a task of T result, and it optionally accepts cancellation tokens and progress reporting objects. Now, if you want to start using this now, you've got two options. You can install the whole thing and patch your compiler and use it, or if you're worried about patching production machines, you install it on a VM and then grab that DLL, that extra 50K DLL, and then use that onto your production machine. And that way, you're only referencing that additive DLL. Now, you won't obviously get the await and async keywords if you do that, but at least you'll get all of those task-based versions. Like, if you want to start preparing for this now, you want to start consuming tasks rather than other forms of asynchrony, and you want to try and start emitting tasks, generating tasks as well when you're programming. So that will help a lot in that transition. One other thing is that if you can download these samples from my website that I've demoed today, but I've also written a much more detailed tutorial on async functions in LinkPad. To get that, you go to LinkPad and click Download More Samples, and up comes this one here, and you click Download into LinkPad, and that will bring this whole library in here, which will give you a complete tutorial on what asynchrony is and why we care, and how tasks work and task completion sorts and so on, and the await and async, and it goes right into that and reactor framework and so on. So that's a good thing to do. So any questions? When is it going to be released into production? It's not known. I suspect it will be next year, but it's not known. Yes, sir? You're talking about the progress reporting? Yes, the additional progress object. It's just a nice way. It's like a mini observable. It's a nice way of reporting additional progress. Now, you could just have one progress object and put extra parameters on the payload. The only difference with that is if the reporting frequency is different, that you might consider that less tidy. But you can, that's another totally valid way of doing it. You can just report progress with a single method, and then the payload in that class has everything on there. That's probably a more standard way of doing it, actually. I just preferred it because the reporting frequency was different. Yes, sir?
Does this make the AJAX ability redundant?
Does it make AJAX ability? They're trying to extend that reach out to everywhere they can. I can't comment on AJAX. I've not tried it at this stage. vNext, it is. That's the aim. This is the next version of C#. We'll have this. That's the idea. Yes, sir.
So, if we were to unit test this, we don't have to add one or two extra keywords to our unit test. It would be something like wait for all or something like that. So like just hit the bottom of that unit test.
Sure. Yes, if you're unit testing it, yep, you can await it. And the great thing is, if you follow the TAP with cancellation and progress reporting, you can even test the cancellation and progress reporting. I mean, you think about use reflection, work out your signatures, and then feed a cancellation token. There's an extension method called cancel after. You can even say, create a token source, cancel in 200 milliseconds. And then you can see whether you actually end up with an operation cancelled exception on that case. You could even test progress reporting, and if it says 5 minutes remaining, you can see whether it really is 5 minutes or whether it's other kinds of minutes. Yes?
Is there a way you can do wait all without passing the tasks? You just await all asynchronous operations in the current thread?
Can you await all asynchronous operations on the current thread? No. You need a handle. That would be a security risk, I'd imagine, amongst other things, and maybe an encapsulation, bad for encapsulation. Yes? Await and async is syntactic sugar. Those translations I showed you, that's exactly what it does. It's like with iterators. It just creates this big ugly class with a state machine.
So if you use the keywords in the identifier and then transfer just the CTP DLL, will things keep working, or do you have to actually manage the tasks yourself?
Exactly. If you write using that CTP and then you transfer your code with that additive DLL, yes, it will work. Yes, that's the idea. Yes?
Does the CTP still work with, or not work with MVC3? I tried down it. It didn't work with MVC3.
There's no reason why the CTP shouldn't work with MVC3. There's some special issue if it doesn't that will hopefully be resolved. Right, okay. I'd be surprised if that wasn't resolved. Yes, sir?
The scenario you're talking about unit testing where you want to progress 5 minutes.
Yes,
If you don't want the unit test to run for 5 minutes,
sure.
the solution is to be able to parameterize the delay, or is there some other way
You'd actually, to be honest, with unit testing, if it took 5 minutes, you're probably not doing unit testing, you're doing integration testing anyway, so you probably be one testing at a lower level, I would expect with that. You can also feed a task scheduler into those tasks, and that can actually help with unit testing. Yes, sir? Yes. Are you asking what I meant by the fine-grained asynchrony? Well, Yep. Yes, it doesn't. Asynchrony doesn't, completely get you off thread safety issues. Is that what you're saying? That? Yeah, sure. Yes. The fine-grained asynchrony, what happens is we saw in the example, the very first one when we're downloading the web page, is that when you have another thread, you've got all those places where you're interacting with the outside world and you have to worry about locking or dispatcher.invoke. That all went away with the async because each time you await an async operation, you've got a transition there where it manages that transfer of data for you through the data in, and then the stuff that you await that comes back out the result. So that's how that I would consider that those are the grains, show them you await. Okay, I think we're out of time now, so thanks very much, guys.